Hello everyone, this is Vikram and welcome to my channel. In this video, we'll understand some of the common AI/ML terms that we use regularly. We'll be doing this in multiple parts, and this video is part of AI/ML foundations that we recently started. So let's try to understand what is a ML model, what is training data, labeled versus unlabeled data, model training, what is machine learning operations, what are LLMs, knowledge cutoff in LLMs, hallucinations, fine tuning. We'll also understand what is prompt and some prompting techniques. So what is a model? In machine learning, a model is a mathematical function that learns pattern from the data to make predictions and decisions. So if you take this is basically a model. Generally, this model is a mathematical function. So a simple linear model can look like something like this. Where you can say x1 x2 are the inputs, b is the bias, and then these are the weights. So the whole model can be represented in the form of a function. It's a mathematical function, and the parameters inside this function, for example, in linear model we call them as w1 w2 up to wn. So these are the parameters that gets adjusted once the model goes through the training, and after that, once you ask any question to the model, it responds based on the learned patterns. So think of this model as a black box, so you don't need to understand what exactly is present inside this model. So the model just take the input and produces the output. For example, you can just show a feed photo of a dog, then the model will just look at the image and say that this is the image of a dog. Similarly, you can give it text input, or you can give it video input. So these are multi-models where they work on multiple types of inputs. A model will have multiple tunable parameters, as we already discussed. These are w1 and w2. So during the process of the training, these weights are adjusted so that model produces the near accurate responses, right? And model training is nothing but it is a process of finding the best values for those models, as I already mentioned, like x1 and x2 are the inputs, and these are the weights and bias. So during the model training, these are adjusted in such a way that if you feed the input, the model that produces the output is near to your expectations, right? Example, if you feed a model an email, it can detect whether it is a spam or not spam. Now coming to the training data, as we already discussed, a model has to go through training, and training data is nothing but collection of examples that we use to tease the model. And as we already discussed, it is nothing but adjusting the weights of the model so that it produces the relevant output. For example, we'll discuss about labeled and unlabeled data in some time. For example, if I just feed the model with this email text, so then it can detect whether it is a spam or not spam. For example, win money now, it is a spam. But if if the model sees meeting at 10 a.m. or lunch at 1 p.m., so it is not spam, right? So the model learns during the training, and if you give it some unseen data or unknown data, it can easily predict the result, it can produce the output. Now during the process of the training, a model can be fed labeled data or unlabeled data. So labeled data in the sense, so we know exactly what is the data that we are using to train the model, right? For example, I know if I have to predict the house price, basically it is dependent on the size of the house and number of bedrooms and other things. So I have this label data where I know the size of the whole house and the number of bedrooms. Then the price is this 2 lakh dollars, right? For example, if it is 1500 sft or square feet and 3 bedrooms, so the price is this. So what I actually do during the process of training is I'll feed this data. So you can say these are the inputs, and then this is nothing but a label. So label in the sense, we also know what is the output. So once you feed it, the model will internally adjust the parameters inside it, and when you give it unknown inputs, right? For example, I can say the square feet is 1200 and I'll say 2 bedrooms. Then model will be predicting the price as an output, right? So this is labeled data. And coming to unlabeled data, so we have the inputs but we don't have the label, right? So I just have the square foot and number of bedrooms, but I don't know the price, right? So in this case, what model will do is, so instead of just giving you the final answer, because it doesn't know what is the final answer, so it will try to find the patterns, okay, based on the inputs. So what it will do is it will form the patterns. So for example, like I have tons of inputs that I fed to the model during the training. So during the process of training, so it will try to form the patterns or understand the relationship between these two, right? And based on this one, it will try to predict the answer. So since we don't know what is the label, or we don't have the label on the data that we used for training, so this becomes the unlabeled data. Now we don't directly feed the entire data. For example, let's say we have probably like 1 lakh PDF pages, or you can say it is a labeled data. So we don't feed that entire data to the model during the process of training. So what we can do is in order to make the model a generalized model, right? So we can just take 70% of the input data and use it to train it, and other 20 or 15% of the data to validate it. So we just feed 70% of the data, so the model will adjust its internal parameters. So now it can produce the output based on the inputs, right? And then how do you validate whether it is producing the right output or not? So we use other 15% of the data to validate it. So during the process of validation, we will again fine tune those internal parameters, right? And then in order to test it, so we use the remaining 15% to finally test the the model. So this is the data split. So the reason why we do is why we don't just feed 100% of the data is we don't want the model to remember or memorize the answers or the outputs. Okay, that's why we just use 70% and then we use the other 30% to validate and test the data. As we already discussed, model training is nothing but adjusting the internal parameters. So you can just say these are the inputs, and then these internally connected lines can be weights, or you can say these are the parameters. So the whole process of the training is involves adjusting these w1 or the other weights, so that the model produces the y, which is an expected value. Okay, as we already discussed, a model can be represented in the form of a mathematical function. Yeah, so we have the data, like we have the inputs, and we also know what is the output, that is the y. So these are used to basically tune this function which represents the actual model. Yeah, so this is model training. Now what is MLOps? So let's say once a model is trained, you have the model which is trained, but how do you deploy the model, continuously evaluate that model, monitor that model, and maintain it in production? So this is where MLOps comes into the picture. So MLOps is nothing but applying DevOps principles to machine learning models to automate them, automate the deployment, monitoring, and managing these models. That is, managing the complete life cycle of these models, anywhere from data preparation to training to deploying them in production, and continuously monitoring them. So this whole DevOps process is nothing but machine learning operations. Now coming to large language models, they are type of AI model trained on massive amount of text to understand, generate human language. For example, let's say I take a model and then I feed the entire English dictionary and other text to that model. So now what that model will do, so that model will try to understand the patterns, adjust it internal parameters, right? So now when we try to ask it any question, it tries to generate the responses just like how the humans communicate, right? So what makes them large in terms of the large language models is basically they are trained on billions of words. They can be books, websites, code samples, or articles, right? Because the size of the data is pretty large, so these are called large language because they use or they generate responses just like how the humans speak, right? So the internal parameters of these models can range from billions to trillions, right? So we talked about W1, W2, so these are the model parameters, right? So they can be from billions to trillions, and they also require huge computing power, thousands of GPUs for them to run. For example, like GPTs, Cloud models, Gemini models, Llama models. LLMs are trained to predict the next word or token in the sequence. Okay, because these are large language model, they have to understand the input and generate the output, which is nothing but the text, right? So the way they operate is they work on they generate the response by predicting the next word or token. So basically, token is nothing but a fundamental unit of data in AI. A token can be a word or part of a sentence or a part of the word, or it can be a single character as well that AI models process, uh, you know or try to understand, right? For example, this can be a token, so this can be a token, ARE can be a token, right? So there are models that can split the whole sentences into tokens. Again, we'll come to it little later. So the LLMs work on predicting the next word in a sequence. For this, LLMs are trained on massive data to get deep understanding of the language, the facts, the relationship between the words, so that they can reason and produce the output. Ask it a question and it generates an answer token by token, right? So even if you see the responses that are generated in ChatGPT and all, you will see that the sentences get typed word by word, or you can say token by token, right? Yeah. So when you say that what is the capital of France, so what model will do is it will start the capital of France is Paris. So this is token by token. So it predicts the next word based on the previous word, right? Then what are multimodal? So we said that LLMs are nothing but large text generation models, but they can also generate images and videos. They are called multimodal. So multimodals are AI models that can work with multiple types of data and not just text, but they can also generate images, audio, video, and many more within a single model. For example, GPT 5.4 Pro, Gemini 3.1, Claude 4.6, Opus, Llama 4. So ask it to generate a presentation or to generate an image, so they can do that because they are multimodals. And what is knowledge cutoff in LLMs? So we already discussed LLMs are trained on massive amount of data. So if we take the data, like we trained the model on December 2024 with the data till December 2024. So that is the latest information that it will have, right? So beyond 2024, if you try to ask it any question, for example, you might ask it to um, you know a question based on some of the events that happened in 2025. So because model is not trained on the data, so model will not be able to answer the data, or in some cases model may try to hallucinate. For example, it may generate incorrect responses or responses that seem genuine but they are not right. So that is called knowledge cutoff. Basically, it is the latest point in time up to which these LLMs have been trained and has information, right? Hallucination. So hallucination is when AI model generates incorrect, misleading, or completely made up information that sound confident and believable, which means even if we don't cross check, we might end up in believing that the responses the LLMs generate are right. So for example, if you ask your model, can you provide a source for the theory of relativity, then so it will give you this theory of relativity, or a link to a link to an ebook or a Wikipedia page, right? So this is the right response because the model knows, what is the theory of relativity, and it can give you the references. What is hallucination is, if you ask the model for the same question, so you can see that model has given a URL which is not related to the question we asked. So what model did was it hallucinated and it created the response. I mean, it generated the response, but it is completely made up information, which is not at all right. Fine tuning. So what is the process of fine tuning is, for example, we take a model. Okay, so we take an LLM or a model which is already available, right? And if you try to ask that model on something which is not known to the model or which is very internal to your organization, right? So in that case, what model will do is model will fail to answer, or it may generate hallucinated answers, right? For example, let's say how to reset our internal tool. For example, I'll say how to reset my internal Jira password. Let's say this Jira is hosted in my organization, which is on a private network. So in this case, what model will do is model will say that you can use default admin username or password, or it may generate something which is very generic, because the model is trained on this specific data. Okay, but if I want the model to answer some of the questions which are very internal to my organization, so what I can do is I can take a model and then tune it or train it on some more data, right? So this some more data is my internal data, and the process of taking a pre-trained model and then giving it a domain specific knowledge, right? This is known as fine tuning. So now once the model is fine tuned, it can easily give the responses from that fine tuned data. Then what is a prompt? So prompt is nothing but a natural language request or an instruction or a question that is given to an AI model. For example, if you take ChatGPT or any other model, so I'm asking it to translate hello to Spanish, so it would give me the answer hola, right? So the question that we asked, right, or the request or the instruction that is passed to an LLM model, this is known as prompt, right? So now prompts can be quite simple, prompts can be quite complex, some can be basic, some can be better, right? For example, if I ask you to explain neural network, so basically this is a very basic prompt, so it will give you a generic response on neural network. But I can also write better prompts. For example, explain how neural networks work for image recognition, including how they detect features and adjust through the training. So this is very specific, the prompt, right? So in this case, it can give you very specific formatted output based on the prompt that you asked for and not the generic one, right? So this is a better prompt. So now there are many prompt engineering techniques. Okay, so prompt engineering is nothing but optimizing the interaction between you and your LLM, right? By structuring the questions or the queries that you ask the LLM model to improve the accuracy and performance. There are many prompting techniques. I'm just gonna show 3 of them. For example, the first one is zero shot prompting. So zero shot prompting involves giving a model a task without showing any examples first. Okay, for example, summarize this article in 5 bullet points. So this is just a generic request that is given to a model. Now what model will do is, so model will generate the response based on what it learned during the training, right? So it doesn't know how to format the response. Probably it may format in the bullet points or directly give you the summary, right? But this is zero shot prompting because we are not asking or we are not giving any examples like how it should respond. Now coming to few shot prompting, this involves giving a model a small number of examples. Okay, so for example, I'll say when I'll just say to my model, if someone says great movie, you can just say it is positive. If the input is it was okay, a bit slow, then I can ask my model to think of this sentence as a neutral sentiment. Okay, now if someone says it is waste of time, you know. So since I've given two examples, so now model will know if someone says it is waste of time, it can fill this response, right? Because now it knows whether it is positive, neutral, or what should be the output, because I've given two examples here, right? So few shot prompting means you're giving the model a small number of examples so that it knows how to respond to your task. Okay. And one shot is a special case of few shot prompting, where you just give a model with exactly one example, right? You just give one example, and the model will follow that example. And then chain of thought prompting, so this is technique which encourages the model to reason step by step, okay, instead of directly giving the final answer. Okay, for example, I want to calculate the ROI for a marketing campaign. So what I'll do is I'll ask the model, explain how to calculate the ROI of a marketing campaign, break it down step by step. So instead of the model directly giving the ROI, okay, it will think step by step, it will show you each step, right? So it will give you all the reasoning, and then it will give you the final answer, right? So this is especially helpful for logic or mathematical type of questions, or multi-step problems and deeper reasoning tasks, where breaking the problem into multiple steps improves the accuracy of the response that the model generates, right? So this way you can make the model think and give you step by step reasoning as well. Okay. Yeah. So so there is a good prompt versus there is a good prompt, there is a bad prompt. So the good prompt is, so you ask the model, or you prompt the model in a very specific format. For example, you can mention the topic it needs to respond, the background, the objective, and the details of the question, right? So in this case, what will happen is the model will think and respond appropriately. For example, I can say, write a 500 word suspenseful crime story set in 1920s Chicago about a detective solving a bank robbery. Okay, so now you can see, it is very structured prompt. So there is a topic, so there is a background, there is an objective, and all relevant details. Another example is generate an email inviting tech conference attendees to post event workshop on cybersecurity best prompts, right? So this is how you clearly, write a prompt. So the example of a bad prompt is, if you don't include any context or details, or if your prompt lacks objective, right? So then it is a bad prompt. For example, write a story, draft an email. So you can see these are all bad prompt. So draft an email means like, what is the subject, or what is the content, right? What is the context basically? So what should how should an email look? What is the content of that email? So we haven't provided any such details to the model. So in this case, what model does is, model will try to ask questions back to you, or it may generate a very generic response, right? So that's it for this video. We'll see more some more AI ML terms that we use in the next video. Thank you.